Hello, good morning. I am Shivran, working as Associate Professor in the Department of Civil Engineering, Vivekananda College of Engineering Technology, Puttur. Right now, we are demonstrating one of the experiments in the basic building material testing lab. So we have experiments on fine aggregate and coarse aggregates. Let us demonstrate an experiment to determine bulk density of fine aggregate. As you have studied, bulk density or in general density is the ratio of weight by its own volume. Weight of the substance divided by volume of the substance. Normally, higher the bulk density, stronger is the substance. So we have materials used in construction, namely sand, aggregate, coarse aggregate, concrete, steel, and etc. So bulk density also takes its own role in determining strength of the concrete, which is the major construction material used in the construction. So we will conduct bulk density for two states of the filling of the sand in the cylinder. One is loose state, second one is compact state or dense state. By conducting this experiment, the students will come to know the difference, what is loose state, what is compact state, whether the bulk density increases when the substance is compacted. Similar concept can be related to the site to understand that when the concrete is compacted, it gets its strength, its density increases. Higher density, stronger the substance. So concrete need to be compacted in the site to get dense concrete and stronger concrete. Also, students will understand the voids, there is a space present between the sand particles. The percentage of voids present in the sand particles with the loose state as well as in the compact state. Also, knowledge of bulk density is required in concrete mix design, that is to determine the proportion of cement, sand and coarse aggregate in the design of concrete mix. Bulk density of the materials also considered, and also to calculate sulfate structure, sometimes bulk density is used. To order materials for the construction, being a professional engineers or contractors, to order the various materials for construction in terms of trucks or in terms of kilograms, with bulk density of any materials to be known. Now, the instruments used to conduct this experiments being, so we have the measuring cylinder of standard dimensions. We have the weighing balance used to measure the weights with the empty and with the filled sand. We have tamping rod used to compact the sand inside the cylinder. Coming to procedure, conduction. Initially, I said in brief, bulk density of sand means weight of the sand inside the cylinder divided by volume of the cylinder is bulk density of sand. The procedure is this. Initially, get the empty weight of the measuring cylinder and note it down. Next, for the loose state, the sand is filled in the cylinder with free fall like this. It is filled full, and I have a cylinder filled with loose sand to the top level. If excess sand is there at the top. The top surface should be leveled, and if excess sand is there at the top, it is removed or surface is leveled by using a tamping rod. Cylinder with the sand being filled in the loose state is weight. This is the second weight of the cylinder plus the sand inside it. The difference of weight, that's the empty weight of cylinder minus the cylinder plus sand, the difference of weight will give you the weight alone of the sand inside the cylinder. The volume of the cylinder is calculated by measuring the diameter of the cylinder and measuring the height of the cylinder. Volume of the cylinder is equal to area of cross section into height. It is calculated in centimeter cube. Weight is measured in grams. If these are observations, sample observations. Specific gravity of sand is assumed as 2.60. It lies in the range of 2.5 to 2.665. So it is assumed at 2.6. Weight of measuring cylinder, empty weight of the cylinder is 2904 grams. Diameter of cylinder is 15 centimeter. Height of cylinder is 17.5 centimeter. Therefore, volume cylinder is equal to pi d square by 4 into h. Give you pi into diameter square by 4 into height. Calculated in centimeter cube, 3092.5 centimeter cube. For a loose state, sand is filled inside the cylinder. Thus, we get weight of cylinder plus loose sand. That is W2 7340 grams. Therefore, weight of the sand alone in the cylinder, W is equal to difference of this weight. W2 minus W1 empty. So if you let this is W1, okay. W2 minus W1 will give you the weight of the sand in the cylinder. Therefore, bulk density is equal to weight by volume, ratio of weight by volume to bulk density. For weight of the sand divided by volume of the sand is equal to 1.43 gram per cc. Percent void space between the particles when it is filled in the cylinder in loose state is calculated as percent void is equal to G minus delta by G, specific gravity minus bulk density divided by specific gravity 100, which gives as 45%, which indicates particles have 45% space inside when the sand is filled in loose state. Now let us understand and demonstrate the specific bulk density of this sand in compact state. For the compact state, the sand should be filled inside the cylinder in 3 layers. Upon the completion of the third layer, the top is leveled. Each layer should be given 25 blows. In short, I can say 3 layer 25 blows. Let us do it. Initially, fill the cylinder with 1/3 sand inside it. Give 25 blows into the sand using tamping rod. It's a tamping rod of standard dimension, 6 mm diameter and 0.5 meter long. It has one end rounded. At this end, the tamping blows should be given from a height of approximately 10 cm. You should count the number of blows. 25 blows should be given, which are evenly distributed. After the completion of the first layer, second layer of sand is filled up to the height of 2/3. Again, second layer is given 25 blows using the tamping rod. Third layer is third layer of sand is filled to the level and 25 blows are given. The top surface is, if any unevenness is there, top surface it is leveled, and top surface is leveled by rolling the tamping rod. The sand in compacted state inside cylinder is weighed using weighing balance, and second weight is recorded, and in the as a sample calculations, let W2 is the weight of the compact sand inside cylinder. Sand plus cylinder is 80-70 grams. Weight of the sand, compacted sand inside cylinder is equal to W2 minus W1. 80-70 minus 2904 is, which gives as 51-64 grams. Therefore, bulk density is the ratio of weight by volume. Weight of the compacted sand below divided by volume of sand, which gives as 1.67 grams per cc. Percentage voids in the sand in a compact state is calculated as G minus delta by G into 100, which gives percentage voids as 35.77%. Now, comparing the bulk density in a loose state and compact state. In a loose state, bulk density is less. When the same sand is compacted 3 layers 25 blows, the bulk density has increased. Similarly, percent of voids in the loose state was 45%, which is compared to high, than the percent of voids which is reduced when the sand is compacted. So, which gives the students an understanding that when the sand or aggregate or in general concrete is compacted in the former, in the construction of beams, slabs, columns, foundations, its bulk density increases. Higher the bulk density naturally gives you stronger concrete, stronger structure. So this test is conducted similarly for post aggregates. It's a separate experiment. Thank you.